Hey everyone, and welcome to this explainer. I am absolutely thrilled to have you here today because we're going to dive into one of the most mind-bending, awe-inspiring, and frankly, magical topics in the entire universe, quantum mechanics. Now, don't worry, we're not going to get bogged down in heavy calculus today. Instead, we're going to demystify this physics using some really clear analogies and show you exactly how it's completely transforming our world. So let's just jump right in with a question to test your intuition. Can a particle be in two places at once? Think about it. In our everyday world, if you leave your keys on the kitchen counter, they aren't simultaneously sitting in the ignition of your car, right? But reality at the microscopic quantum level, it completely refuses to follow those everyday rules. The short answer to this question, when we're talking about the tiny building blocks of the universe like electrons and photons, is actually yes. Welcome to the incredibly weird, wonderful quantum realm. Here's our roadmap for today's explainer. We'll start with the weird quantum world, then move into teleporting across 270 meters, look at quantum 1.0 versus 2.0, and finish up with our trillion-dollar quantum future. Let's get started with Section 1, the weird quantum world. Okay, to really understand this, we have to temporarily forget absolutely everything we know about how classical objects, like baseballs, cars, the moon, how they behave. We gotta wipe the slate completely clean and look at a concept called quantum entanglement. This describes a state where two particles become so deeply fundamentally connected that measuring the properties of one instantly affects the other. And I mean literally instantly, regardless of the physical distance between them. They could be sitting across a microscopic chip from each other, or they could be on totally opposite sides of the known universe. Wait, what? Yeah, if your brain is hurting just a little bit right now, you are in great company. Albert Einstein himself absolutely hated this idea. He famously called it spooky action at a distance. It bothered him tremendously because it really seemed to violate his theory of relativity, which basically says nothing can travel faster than the speed of light. So how could two particles communicate instantaneously? It just sounded impossible. To kind of wrap our heads around this, let's use a couple of analogies from the Science Atlas and Caltech. First, imagine the magic coins. Let's say you and I each take an entangled coin to opposite ends of the galaxy. The exact moment you flip yours and it lands on heads, my coin instantly becomes tails. It doesn't actually decide what it is until you look at it. Wild, right? But another really beautiful way to picture this is the ballet dancers. Think of a complex ballet or a tango. The dance isn't just one person or the other doing their own thing. It's an emergent connection where two totally separate entities are moving perfectly as one unified system. That's entanglement. Moving right along to Section 2, teleporting across 270 meters. Because, guys, this isn't just chalkboard theory anymore. It is actively happening. 270 meters. In this stunning recent breakthrough, an international team of scientists, including researchers over at Paderborn University and Sapienza University in Rome, literally teleported quantum information between two separate quantum dots across a 270-meter open-air link right between two buildings. They proved that this quantum information can actually travel between totally independent devices entirely outside of a perfectly controlled lab environment. Now, we definitely need another crucial wait what reality check here. We are teleporting information, not matter, okay? So this isn't Star Trek, we aren't beaming Captain Kirk down to an alien planet, and we aren't even physically moving the photon particle itself. What these scientists actually did was take the exact quantum state, specifically the polarization state of a single photon, and transferred that exact state to another, physically separated photon. The original photon state is completely destroyed, and the receiving photon perfectly adopts it. But the absolutely crucial point here is how well they actually did this. They achieved an incredible 82% fidelity in the teleported state. To pull this off out in the open air, fighting wind and atmospheric turbulence, they had to rely on ultra-fast single-photon detectors and GPS-assisted synchronization. Hitting that 82% accuracy is just a massive leap forward. And why does this matter so much? Because this is the exact foundational tech we need to build quantum relays. And those relays? They are the building blocks of an ultra-secure, completely unhackable, large-scale quantum internet. All right, let's shift gears to Section 3, Quantum 1.0 versus 2.0. We so often talk about quantum tech as if it's purely this futuristic sci-fi concept. But according to classifications used by the UK government and researchers all over the globe, you already rely on Quantum 1.0 every single day of your life. The lasers in your supermarket checkout, the MRI machines at your local hospital, the fiber optic broadband piping the internet into your home, and even the semiconductor chips powering the very device you are using to watch this right now. All of that relies on foundational quantum mechanics. But quantum 2.0? That is what we are entering right now. This is the era where we are actively manipulating specific, delicate quantum properties, things like superposition and that spooky entanglement we just talked about, to create next-generation quantum computing, ultra-sensitive gravity sensors, and teleportation-based communications. And honestly, it gets even wilder. Quantum 2.0 isn't just about faster microchips. It's fundamentally about life itself. Researchers are now diving deep into quantum biology. There's emerging evidence showing that quantum effects might actually explain how birds use a magnetic compass to navigate across the entire globe, or how plants achieve such mind-blowing energy transfer efficiency during photosynthesis. We're starting to realize that nature has literally been utilizing quantum mechanics for millions of years. Which brings us to our final act, Section 4, our trillion-dollar quantum future. Understanding how a bird navigates or how a photon teleports is translating directly into some of the most lucrative and highly useful real-world technologies humanity has ever seen. According to McKinsey, quantum computers don't just do regular classical math faster, they actually solve incredibly complex combinatorial problems and simulate the underlying physics of nature in ways that classical computers simply can't do. For example, in chemicals and life sciences, researchers are using quantum computers to simulate molecular interactions to rapidly speed up drug discovery. In travel and logistics, they are optimizing insanely complex routing constraints. And in agriculture, think about this. About 2% of the entire world's annual energy output goes into the Haber process just to make fertilizer. Quantum simulations could completely overhaul this chemical process, drastically reducing global energy usage. And going way beyond just computing, the practical uses on the immediate horizon for quantum 2.0 sensors and communications are huge. We're talking about completely unhackable quantum encryption, known as quantum key distribution. We'll have these hypersensitive quantum sensors that can pinpoint invisible methane leaks to actually help us hit net zero emission goals. We're developing quantum gravity sensors that can literally see underground before we start digging for major infrastructure projects. And we're creating quantum timing devices that provide incredibly reliable alternatives to GPS, which is absolutely vital for national security if satellites were to ever fail. So this is exactly why we are sitting at a massive commercial tipping point. $2.7 trillion. According to McKinsey's Quantum Technology Monitor, that is the projected global economic value of quantum computing alone by the year 2035. This is no longer just some theoretical physics debated in university basements. Over 300 global companies, massive giants like Airbus, JP Morgan Chase, and Boehringer Ingelheim, they are actively collaborating with quantum tech companies right now. They know for a fact that the first movers in this space are going to define the future standards of virtually every single industry. Which really leaves us with one final thought. We started out today with this spooky, mind-bending physics that even Einstein himself doubted. And we've landed on a technology that is actively rewriting our capabilities in medicine, logistics, communications, and global security. The magic is very real, and it is highly lucrative. The quantum century is already here, so the only question left is, are you ready? Thank you so much for joining me for this explainer. Keep learning, keep asking those big questions, and I'll catch you next time.